Thank you, Shulamite, and good day, everyone. I am Shine Leslie Kanda, and I'll be discussing about the applications of modular arithmetic, focusing on check codes. So, as you can see in these images that I got from Google, so from the credit card, bank accounts, and to barcodes from all the products that we purchase every day in the supermarket, those are actually using modular arithmetic. So, at this point, we are going to discover as to how really modular arithmetic is being used with this kind of identification numbers. So we with this section we will cover the UPC, the USPS, the credit card, and the ISBN, which they use as check digits as their last digit to ensure that the number is valid. So we will tackle them one by one. So the UPC, or the Universal Product Code, that was developed by George Joseph, is used by many of the products sold in supermarkets which contain identification numbers. So the total digits in UPC is actually 12, and the last digit is the check digit. So here we have the European article number, or it is also known as the International Article Number. And the most commonly used AAN standard is the AAN 13. So look at figure 11.1. There we have the sample of UPC and EAN 13. So let's move on to the check digit formula of UPC and EAN 13. So as you can notice, both uses modulo 10. And in UPC, all the ang subscript digit is odd number, ang i-multiply by 3. Whereas in European article number, all subscript number or all even subscript numbers are to be multiplied by 3. So let's take a look at these examples using or applying the formula. So determine the check digit for the new product, and the first 11 digits are given. So we will going to find the check digit of the new product. So we will let D sub 1 is congruent to 7, D sub 2 is 8, D sub 3 is 7, D sub 4 is 6, D sub 5 is 3, D sub 6 is 4, D sub 7 is 7, D sub 8 is 3, D sub 9 is 2, D sub 10 is 1, and D sub 11 is 4. So after that, we are going to apply the formula of UPC, which is D sub 12 is congruent to 10 minus 3D sub 1 plus D sub 2 plus 3D sub 3 until 3D sub 11 modulo 10, in which all odd subscripts are to be multiplied by 3. So after that, we are going to substitute all the digits. So we have the next step, which is D sub 12 is congruent to 10 minus 3 times 7 plus 8 plus 3 times 7, and so on and so forth, modulo 10. So after that, we are going to multiply. So we have now that D sub 12 is congruent to 10 minus 21 plus 8 plus 21, and so on and so forth. So after that, since wala na kinahanglan i-simplify, we are now going to add all the digits in the parentheses. So D sub 12 is congruent to 10 minus 112 modulo 10. Since the first reporter, which is NASA, mentioned that modulo is the remainder after dividing one number by another. So we are going to divide 112 by 10. And we are going to pull out the remainder of 112 divided by 10. So the remainder is 2. So D sub 12 is congruent to 10 minus 2. So D sub 12 is 8. Thus, the check digit is 8, and the UPC of the new product is 78763473214 So, next example would be determine the check digit of EAN 13 number. So, we are going to look for the check digit of the EAN 13 using that numbers that is provided, and also using or applying the formula of EAN 13. So same process as what we have done earlier in the first example. We are going to substitute all the digits, and we are going to multiply all those even subscripts, all those nga ang subscript is even, by 3. So after multiplying, we are going to add all the digits in a parentheses. Now we have D sub 13 is congruent to 10 minus 65 modulo 10. So the remainder is 5. So 10 minus 5 is 5. So thus the check digit is 5 and the EAN 13 is 9310779300005. So that is all about UPC and the EAN 13. Let's move on to the ISBN of a book. So it is usually found on the last cover page. So it is in a string of 10 or 13 digits. So some ISBN is 10, some pod is 13. So I guess we are all familiar with ISBN since Modularize here are fond of reading or buying books. So let's move on to the formula since the last digit also serves as their check digit. So we have a separate formula of ISBN with 10 digits and ISBN with 13 digits. So as you can see, they're very different from each other. So let's take a look at these examples applying this formula. So check whether ISBN 9786214060641 of the Book of General Mathematics for Senior High School is valid. So same process as what we have in UPC and EAN 13. We are going to let D sub 1 until D sub 12 to its corresponding digits that is provided in the situation. So after that, we are going to use D sub or like the check digit formula of ISBN with 13 digits since the given ISBN is 13 digits. So we were going to check if the check digit budget is 1. So we will do the substitution and then after substituting, same as with the EAN 13 na ang kadtong subscription if the subscript is even number, then you are going to multiply it by 3. So after multiplying, since wala na kinahanglan pa simplify, we are now going to add all the digits in the parentheses. So D sub 13 is congruent to 10 minus 89. 89 is the answer after adding all the digits in the parentheses, modulo 10. So 89 divided by 10, we have the remainder 9. So 10 minus 9 is 1. So 1 ang result and 1 po ang nasa ISBN last digit. So the number is valid. So another example, determine the ISBN check digit for the book Discrete Mathematics and the first 9 digits of the ISBN are given. So we will look for the check digit. So here, the provided ISBN is 10 digits only. So we will use the ISBN with 10 digits formula. So same process again, we will substitute the digits and after substituting, we will multiply it with the formula, with the given formula. So numbers are given formula. So after multiplying, we will add all the digits in the parentheses, and now we came up with D sub 10 is congruent to 11 minus 122 modulo 11. So 11 minus 1, since 1 is the remainder, after dividing 122 divided by 11, so 11 minus 1 is 10. So 10 is a 2-digit number man. So we will not add 2-digit number in as check digit. So instead of 10, we will use its Roman numerical equivalent, which is X. So the check digit is X and the ISBN of the book is 013215286X. So the X there indicates 10. Next, let's move on to the another one. A bank routing number is a 9-digit number used to identify bank from which the check is issued. So unlike the previous ones, so it does not have a check digit. It is more of an error detecting code in order to verify the given number is correct. So dili siya magamit og check digit. So look for the formula. So, di ba, ang formula po niya is different from what we have earlier. So instead of D, then subscript, naa siya, ang kuan niya is 0. So we're going to test if the number is divisible jud siya by 10. So, say for example, show that the bank routing number used by BPI is valid. So, the bank number is 0100400018. So, we will apply the formula. So, same process again. with a different formula. So we're going to do the substitution. After substituting, we are going to multiply it kung unsang na given sa formula and then modulo 10. So after multiplying, we will add all the digits in the parentheses and we will test here if ang result is 0 bagid siya, if divisible bagid siya by 10. Since 90 after adding all the digits, 90 ang result, so 90 divided by 10 is 9 and 9 times 10 is 90. So wala siya remainder. Hence, the bank routing number used by BPI is valid. Next is the United States Postal Services, or the USPS, consists of 11 digits, while the credit card number consists of 16 numbers where their last digit also serves as their check digit. So the figure 11.5 shows an example of credit card. So the formulas, here are the formulas of USPS and the credit card. And the credit card, it is using loan algorithm, which means kinalan siya nga we will add all the digits, treating two digits number as two single digits, and we will multiply all the digits of even rank by 2. Let's see for an example. So, example 1, determine the serial number of USPS money order is valid. So we will use the formula of USPS and we will substitute all the digits. So we will substitute the given digits in the formula. So d sub 11 is congruent to 9 minus d sub 1 plus d sub 2 until d sub 11, d sub 10 modulo 9. So we will substitute after substituting, since wala na kinahanglan pa i-multiply, wala na kinahanglan i-simplify, we will now add all the digits in the parentheses. So we have d sub 11 is congruent to 9 minus 47 modulo 9. So the remainder is 2. So d sub 11 is congruent to 9 minus 2. So we have 7. However, 7 is the check digit. But in the serial number, it is indicated with 5. So it should be 7, not 5. Thus, the money order is invalid, or there might be forgery of money order. So that is for USPS. Now we are going to move on to the credit card. So we will test if the credit card number presented is valid. So we will use the formula for check digit in credit card rather. And so we have D16 is congruent to 10 minus 2. So we're going to substitute all the digits. After substituting, we will multiply by 2. Then after multiplying, we will add all the digits. And after adding, we can see that there are 2 digits, or actually 2 hakakan number nga, 2 digits siya. So instead of 2 digits, we will make it we will treat it as 1 digit. So para mahimo siya 1 digit, we are going to add 1 plus 4 and 1 plus 2. So 1 plus 4, nahimo na siyang 5. Instead of 14, nahimo siyang 5. Ang 12 po, instead of 12, gi-add ang 1 ug 2, nahimo siyang 3. So we are going to add everything na, since wala na kinahanglan pa nga i-simplify. So d sub 16 is congruent to 10 minus 67 modulo 10. So 67 divided by 10. So the remainder is 7, and we will going to minus 10 minus 7, which is 3. So the check digit is 3 and the credit card number is valid. So that would be all from our report. So as you can see in the picture, I know you can do this math. So I know it would be easy for you if you're going to try answering the exercises found in the Moodle. So math is everywhere indeed. Just like this one, we may not realize it, but we use this kind of modular arithmetic application every day. And that would be all, everyone. I hope you are learning something from me, and I will now pass you on to my groupmate, Syra Ray Pinos, to discuss another application of modular arithmetic. Thank you and God bless.